Welcome back. In this video, we are going to take a look at how we can do some sort of bivariate analysis using Excel. We've already taken a fairly detailed look at how we can do arithmetic using Excel and how we can extend that arithmetic to do univariate analysis on continuous as well as discrete columns. Here, let's take a look at what happens when we try to do bivariate analysis. Now, as we know, in order to do bivariate analysis, we are going to need two columns, either a pair of continuous columns or a continuous and a discrete columns. So let's start with a pair of continuous columns, which is sepal length and sepal width. So we know that one of the most useful graphical ways of checking correlation or essentially dependence between two continuous variables is to look at a scatter plot. So we have selected these two columns, and since scatter plot is a chart, we can just go to the insert tab over here and then click on this particular button here, which simply says XY scatter. So we just click on this and there we have it. This is basically the scatter plot of sepal length versus sepal width. And you might have expected that if sepal length grows, then sepal width also grows, but that doesn't seem to be the case over here. In fact, if you look at this blob here, what that tells us is that there is no increasing or decreasing sort of a strict relationship. Now, that is something that we have inferred by simply looking at this particular plot. We still do not have a quantitative idea of how much correlation there is between the sepal length and the sepal width. And of course, we have a formula directly to compute it, which is called simply correl. And there we just say that we want to give it an array, basically a pair of arrays, array 1 and array 2, and it's going to compute the correlation between them. So let's say that I want to fill in my array. I can just click on A over here. So if it fills in A colon A for us, and then I put a comma, space, and then I click on B, which is B colon B, and I finish the parenthesis and I press enter. So that's basically the correlation between sepal length and sepal width. And surprisingly, you see, it's actually, it has a negative sign, which means that there is negative correlation between the sepal length and sepal width, which means that as one increases, the other doesn't increase, it decreases. And even that relationship, even the decreasing relationship between them is very small, because the magnitude tells us that it's a very small magnitude. It's in fact 0.08, which means that the extent to which one decreases as the other increases is very small, and the sign basically tells us whether it's an increasing relationship or a decreasing relationship. And now what we graphically saw from this, we basically saw that there is almost no correlation. These are mostly randomly scattered values. That is reflected by the very tiny value of correlation that we are getting here. And basically, as one increases, the other decreases. That is not something we could have inferred by simply looking at this. So that is given by the mathematical quantity. The negative sign tells us that there is a decreasing relationship. Now, petals are a far more, important characteristic of a flower, and you might expect that bigger petals mean that as a petal length increases, the petal width also increases. So we might expect to find positive correlation between these two columns. Let's try that as well. Let's select the petal length column and also the petal width column, then go back to the insert tab, click on the XY scatter menu, select the scatter plot, and there it is. That's basically the scatter plot of petal width versus petal length. And we see that there is a fairly linear trend over here. Of course, there is a cluster over here and there is another cluster over here. As you might have guessed, these clusters depend on the species. So this is basically one species, and this is a combination. This large cluster that we see over here is a combination of the other species. Now graphically, again, looking at this might lead us to believe that there is a very high positive correlation between petal width and petal length. But in order to actually verify this value, let's also try and do the correlation. And we have the first array, which is petal length, which is the C column. So we say C to C, and then we say D to D for petal width, and then we press enter, and we get a value of 0.96. So the magnitude of the value, which is very high, indicates that there is indeed a very strong correlation between petal length and petal width. Obviously, as one increases, the other also increases, and that increasing relationship is given to us by the positive sign, and there is a very high correlation. So the relationship between them is very dominant. So this is broadly how we do bivariate analysis between a pair of continuous variables. We draw a scatter plot and we look at the correlation. So we have the graphical and the mathematical aspects both covered with Excel. However, we still haven't considered what we can do when one of our variables is categorical and the other is a numerical variable. As you remember from the previous video, what we do in this case is something called grouping and aggregation. You group any particular continuous variable, let's say something like petal width, by each unique value of species that occurs, and then you try to do some aggregation on that individual group. The easiest way to do this in Excel is something called a pivot table. So let's select an empty cell, we go to the Insert tab, and then we click on Pivot Table. So that basically asks us to select a table or a range. Now the table that we want to consider is basically this one. So it's all the sepal length, length, petal width and the species column, and we want to essentially insert this into the existing worksheet. We don't want to create a new file, so we leave this particular option selected and then we click on OK. And that basically gives me my pivot table over here. Now in order to populate this pivot table, I can look at this menu over here. Now here what I say is that along the rows of this pivot table I want species. So basically I drag species from the field name menu over here into the rows menu over here. And that gives me all the row labels, Certusa, Versicolor and Virginica. And the blank are basically because we have values that are extending beyond row 139 as well. We can ignore that for now. And then we say that the values that I want are, say, the sepal length. So I drag the sepal length down to the values column. And you see that it says that it's giving me the sum of sepal length. Now what if we don't want the sum of sepal length? Well, I can just right click on this particular element over here and I can go to field settings. And here it basically says that sum of the sepal length is the field name and it is summarized by sum. However, I can change it to average, to count, max, min, anything I want. So let's take average for now. So that's basically average, and as you see, the field name changes to average of sepal length, and then I click on OK. So what this means is that for Setosa flowers, the average sepal length is this much. For versicolor, the average sepal length is that much, and for virginica, it is that much. Now, of course, I can do the same with all other values, that is, all other types of numerical columns. So this is one case of bivariate analysis. I have taken one particular categorical column, I have taken another numerical column, and I have applied some sort of aggregation on that column, which in this case is the average. I can add the sum as well. So let's say I want to simply click on this again, and that gives me my menu back. I say not only I want the average, but I also want the sum. So again I can drop sepal length into the values menu over here, and here again I get the sum. Let's remove the sum for now, because anyway it's not going to help us much. So let's say I can just right click on the values field again and do a remove field. So I can also drop sepal width, I can drop petal length, I can also drop petal width. So here is my entire pivot table where I say that I have against the Setosa species the average sepal length, the total sepal width, the total petal length and the total petal width. Now of course, like we demonstrated earlier, we can change these aggregations from sum to average. So basically basically sum to anything else. So let's say I click on this, I right click on this, and then again I go to field settings, and when I look at this I can just do an average, and I can do basically this becomes my average. Again here I can right click on the sum of petal length, I can go to field settings again, and then I can do a minimum instead of a sum or an average. So basically that is my minimum value. So there it is. We have basically one categorical variable, we have 4 numerical variables, and we have 4 different aggregations specified against all of them. So this is something that lets me perform bivariate analysis when both my columns are of a different type. That is, one is categorical versus other is numerical.